committed to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
On July 20th, 1969, mankind accomplished its single greatest achievement of all time. The Apollo 11 mission was the first manned mission to land on the moon. Launched on July 16, 1969, it carried Commander Neil Alden Armstrong, Command Module pilot Michael Collins, and Lunar Module pilot Edwin Eugene Buzz Aldrin, Jr.
For the third stage of the Saturn V launch vehicle. This is ground support equipment located on the tower at the pad.
In addition to 1 million people crowding the highways and beaches near the launch site, an estimated audience of over 700 million people viewed the event on television, a new record at that time. President Richard Nixon viewed the proceedings from the Oval Office of the White House,
giving a helping hand to the 3 prime crewmen as they start to perform some of their preliminary checks.
Clock start flight, roger.
We have a liftoff. 32
Thrust go, all engines, roger.
T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 36 past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on proper heading.
Clock start flight, roger.
We have a liftoff. 32
Thrust go, all engines, roger. Flight final, go with the IP. Roger, IP.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on proper heading.
Flight range safety is nominal.
30 seconds.
Roger, RSO.
Roll complete and the pitch is programmed. One Bravo.
Flight range safety is all in the water. Roger, RSO. Roger.
Altitude.
Kevin, we're leaving. Roger, how you, booster? We're going to flight. Good at 1 minute, Cap, now.
Apollo 11 Houston, you're good at 1 minute. Downrange 1 mile, altitude 3, 4 miles now. Velocity 2,100
Fido, flight, how you?
per second.
Looking good, flight. GNC? Looks good, flight. Econ? Looking good, flight. Roger.
We're through the region of maximum.
Booster flight, how you? We're go flight. Surgeon. We're go flight. Everything's good. Roger.
The Saturn V carrying Apollo 11 took several seconds to clear the tower on July 16, 1969. The Saturn V launched Apollo 11 from the Kennedy Space Center on July 16, 1969 at 9:32 a.m. local time. It entered Earth's orbit 12 minutes later. After 1.5 orbits, the Saturn IV third stage engine pushed the spacecraft into its trajectory towards the moon with the translunar injection burn. About 30 minutes later, the command service module pair separated from the last remaining Saturn V stage and docked with the lunar module still nestled in the lunar module adapter.
Downrange 30
How you,
miles,
Econ?
30 miles
Go
an hour,
flight.
standing by.
GNC.
This is Houston, how do you read? Right.
Apollo 11, this is Houston, broadcasting in the blind. Request Omni Bravo, if you read us. Request Omni Bravo. Out. Apollo 11, this is Houston, how do you read?
Goldstone still showing weak signal strength.
Apollo 11, this is Houston, how do you read? Over. Apollo 11, this is Houston, do you read? Over. Apollo 11, this is Houston, radio check, over.
Invasion of the undocking. I have all available windows either full of heads or cameras, and I'm busy with other things.
We concur, over.
Okay.
And Eagle, Houston, we'd like you to select Aft Omni now. It'll be good for both LOS and AOS, over.
Roger, going to Aft Omni.
Houston, 1 minute, LOS.
Columbia, right? How are Columbia systems looking, you guys?
This is Apollo Control. We've had loss of signal now. We'll reacquire the spacecraft again on the 13th revolution in about 45 minutes. At the end of this pass, we passed along the go for undocking. That maneuver will occur just before we reacquire the spacecraft on the 13th revolution, and will be followed in about 30 minutes later by a small separation maneuver performed by Mike Collins in the command module. The checkout of the LEM has been going extremely well, up to now ahead of schedule, and both vehicles look very good. At 99 hours 31 minutes, this is Apollo Control, Houston. This is Apollo Control at 100 hours 14 minutes. We're now less than 2 minutes from reacquiring the spacecraft on the 13th revolution. When next we hear from them, the lunar module should be undocked from the command and service module. We're presently about 25 minutes away from the separation burn, which will be performed by Mike Collins in the command module, to give the LEM and the CSM a separation distance at the descent orbit insertion maneuver of about 2 miles. We have some times on the upcoming events. The separation maneuver is scheduled to occur at a ground elapsed time of 100 hours 39 minutes 50 seconds.
This seemed to enable a satisfactory high bit rate condition, but It did degrade our ability to observe the surface through the LPD and make down and cross range position checks.
As I recall, and this is why I kind of like to have those tapes, there was a certain amount of manual tracking being done during this time with the S-band antenna. During the initial parts of powered descent, the auto track did not appear to maintain the highest signal strength. It dropped down to around 3.7, and the ground wanted reacquisition, so I tweaked it up manually. I got the impression that it was not completely impossible to conduct a manual track throughout powered descent. You'd not be able to do very much else beside that. I think it would be possible to do if you had sets of predetermined values that you could set in case you ever did lose completely.
At DOI ignition, which was our first dips maneuver, I could not hear the engine ignite, couldn't feel it ignite, and I wasn't, the only way I was sure that it had in fact ignited was looking at chamber pressure and the accelerometer. It's a very low acceleration level while you're at 10%, just off zero. And
What's 10%?
Yeah.
Just doesn't put out the...
Oh, I think it would, you know, after 0G, it would throw you against your straps one way or the other. It would be very apparent.
Now we're pulled down into the floor with the restraint already, and the difference between that and the 10% throttle acceleration was not detectable to me. However, at 15 seconds when we went to 40%, it definitely was. Our downrange position appeared to be good at the -3 and -1 minute point. The ignition point I did not accurately catch because I was watching the engine performance. But it appeared to be reasonably certainly in the right ballpark. Our cross-range position was difficult to tell accurately because of the skewed yaw attitude that we were obliged to maintain for comm. However, the downrange position marks after ignition indicated that we were long. Each one that was made indicated that we were 2 or 3 seconds long in range, and the fact that throttle up essentially came on time rather than being delayed indicated that the computer in fact was a little bit confused in what our downrange position was. Had it known what it was, it would have throttled down later based on engine performance so that we would still hit the right place if in fact it knew it was downrange by a couple of seconds. Then it would be late to throttling down so that it would brake more at a higher throttle level prior to the pitch. Landmark visibility was very good. We had no difficulty determining our position throughout all the face-down phase of powered descent, and correlating that with known positions based on the Apollo 10 pictures was very easy and very useful.
It was just about at the yaw around maneuver when we, well, I guess trajectory monitoring from the Disky up to that point agreed very closely, especially in H-dot, in VI with the values we had in the chart. The altitude values were, maybe off by something approaching 500 feet, but again, they were, quite close. It was almost immediately after yaw around that, as I recall, the altitude light went out, indicating that we had landing radar acquisition and lock-on. And what do you recall it being? 2,300 feet, something like that?
26 or 700, I believe, is the number I remember. I think it was plus 26 or 27. The yaw around was slow. We had inadvertently left the rate switch in 5 rather than 25, and I was yawing at only a couple degrees per second as opposed to the 5 to 7 that we'd planned. And the computer would not hold this rate, say 1 to 2 degrees a second. It was jumping up to 3 and back to actually changing the sign and stopping the roll rate. And it was then that I realized that clearly we weren't rolling as fast as we needed to be, and I noted that we were on the wrong scale switch. And, so I went to 25 and put in a 5 degree per second command, and it went right around. But this delayed us somewhat, and consequently we were at a slightly lower altitude at the completion of the yaw round than we had expected to be. So we were probably down to the area of 39 or 40,000 feet at the time when we had radar lockup, as opposed to about 41,000 that we expected to be at 41.5.
I guess the first indications we had of anything going wrong were probably around 5 minutes or something. When they first started getting program alarm activities.
After the 5 minute into descent, we started getting a series of program alarms, generally of the series that indicated the computer was being overloaded. And normally in this time period, we'd normally be evaluating the landing site and checking our position and starting LPD activity. However, the concern here was not with what was the landing area we were going into, but rather could we continue at all. And consequently, our attention was directed toward clearing the program alarms, keeping the machine flying, and assuring ourselves that control was adequate to continue without requiring an abort. And most of the attention was directed inside the cockpit during this time period, and in my view, this accounts for our inability to study the landing site and final landing location during final descent. It wasn't until we got below 2,000 feet that we were actually able to look out and view the landing area.
Okay, looks like it's hold.
Okay, I see something here that answers a question we had before about the AG's residuals on DOI. They were
7 minutes, 30 seconds into
1/10 before nulling, and we nulled them to 0.
altitude 16,000.
X was minus 0.1, Y minus 0.4, Z minus 0.1, and we nulled X and Z to 0.
Good. Eagle, Houston.
And looking at the transcripts, we did have considerable loss of lock approaching PDI. And we did have to reacquire manually several times.
Roger, stand by. You're looking great at 8 minutes.
And it looked like we had some
760 feet per second.
It's the P-64.
oscillations in the yaw angle on the antenna.
Fido says we're go. Altitude
And the alarm that we had was 500. And we went to descent 1 and proceeded in the computer, and then went back to auto again on the landing radar switch. And this is prior to ignition again, and the ground recommended we yaw right 10 degrees.
Coming up 9 minutes.
We did not have the radar data feeding to the computer in the LGC position, but apparently even if you have it in auto track, why there's some requirement on the computer's time to
Altitude 42. Houston, you're a go for landing, over.
This is the way we've been doing it
Go for landing, 3,000 feet.
in all simulations. It was our agreed on
1201. Roger, 1201 alarm.
method.
We're go, same tide, we're go. 2,000 feet. 2,000
We were in
feet.
sloop.
Into the ag, 47 degrees. Roger.
Yeah, we were, prior to this time, we'd been in auto track until such time as we started to lose lock in the pitch over, and then we went to sloop.
Eagle looking great, you're go.
Isn't that right?
Altitude 1,600.
I'm talking about the program alarms during descent. We'd passed the point of having the rendezvous radar in auto. We'd switched it over to slew at that point. Just left it there.
750.
In the early phases of the P-64, I did find time to go out of auto control and into manual and check the manual control in both pitch and yaw, and found its response to be satisfactory, and then zeroed the air needles and went back into auto. Continued the descent in auto at that point.
Cape forward. 10 and 50 feet down.
As we approached the 1,500 foot point and the program alarm seemed to be settling down and we committed to continue, we could see the landing area and the point at which the LPD was pointing, indicating we were landing just short of quite a large blocky rim crater surrounded with a large boulder field. I initially felt that might be a good landing area if we could stop short of that crater and find a suitable place, since it would have a lot of scientific value to be in that area close to this large crater. Upon continuing to monitor LPD with time, it was obvious that I would not be able to stop sufficiently short of that crater to find a safe landing area, and as soon as we determined that, we went into manual and I pitched the vehicle over to approximately zero pitch, and I think I was in the 20 to 30 foot per second horizontal velocity region here, over the top of the crater and across the boulder field, and then proceeded to look for satisfactory landing area at about 100 feet, or a little below 100 feet. I first noticed that we were in fact disturbing the dust on the surface, and we were beginning to get a transparent sheet of moving dust, which obscured the visibility a little bit. As we got lower, this visibility degradation continued to increase, and don't think that the altitude determination was severely hurt by this blowing dust, but the thing that was confusing to me was the fact that it was hard to pick out what your lateral and downrange velocities were, and that's because you were seeing a lot of moving dust. You had to look through that and pick up the stationary rocks and base your translational velocity decisions on that, and I found that to be quite difficult, more difficult than I thought it would be, and I spent more attention trying to arrest translational velocities than I thought would be necessary.
That's one small step for man, one giant leap for mankind.
the surface is fine and powdery. I can pick it up loosely with my toe. It does adhere in fine layers, like powdered charcoal, to the sole and sides of my boot. I only go in a small fraction of an inch, maybe an eighth of an inch, but I can see the footprints of my boots and the treads in the fine sandy particles.
Neil, this is Houston. We're copying. Okay, that looks good there, Neil.
Yeah, that looks good there, Neil. Okay.
One hour, 7 minutes time expended.
Okay, you can make a mark, Houston.
Roger, slow in.
And incidentally, you can use the shadow that the staff makes to assist you in getting it perpendicular.
Buzz is erecting the solar wind experiment now.
Some of these small depressions take off, and you tend to think, oh, maybe 2 or 3 inches. I can see just exactly what the layer pictures showed when they pushed away a little bit. You can see force transmitted through the upper surface of the soil, and about 5 or 6 inches away, it breaks loose and moves as if it were caked on the surface, when in fact it really isn't.
I notice in the soft spots where we have footprints nearly an inch deep that the soil is very cohesive, and it will retain a slope of probably 70 degrees on the side of the footprint.
All limb systems still looking good.
Okay.
Yeah, I think that's next.
Setting up the flag now.
Great.
I guess you're about the only person around that doesn't have TV coverage of the scene.
That's all right, I don't mind a bit. How is the quality of the TV?
Oh, it's beautiful, Mike. It really is.
Oh, geez, that's great. Is the lighting halfway decent?
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface.
Beautiful, just beautiful.
Coming up on 2 minutes. Mark, 2 minutes, T-minus.
Aldrin entered the Eagle first. With some difficulty, the astronauts lifted film and 2 sample boxes containing more than 22 kilograms of lunar surface material to the lunar module hatch, using a flat cable pulley device called the Lunar Equipment Conveyor. Armstrong reminded Aldrin of a bag of memorial items in his suit pocket sleeve, and Aldrin tossed the bag down. Armstrong then jumped to the ladder's 3rd rung and climbed into the lunar module. After transferring to life support, the explorers lit the Ascent stage for return to lunar orbit by tossing out their PLSS backpacks, lunar overshoes, 1 Hasselblad camera, and other equipment. They then repressurized the lunar module and settled down to sleep. While moving in the cabin, Aldrin accidentally broke the circuit breaker that armed the main engine for liftoff from the moon. There was initial concern this would prevent firing the engine, which would strand them on the moon. Fortunately, a felt-tip pen was sufficient to activate the switch. Had this not worked, the lunar module circuitry could have been reconfigured to allow firing the Ascent engine. After about 7 hours of rest, they were awakened by Houston to prepare for the return flight. 2.5 hours later, they lifted off in Eagle's Ascent stage, carrying 21.5 kilograms of lunar samples with them to rejoin Michael Collins aboard Columbia in lunar orbit.
Got that answered, Coach? 26, 36 feet per second up. 5 for the pitch over. Very smooth. Balance couple off. Very quiet ride. There's that 1 crater on there.
Thousand feet high, 80 feet per second vertical rise. Eagle Houston, request manual start override.
Roger.
2,600 feet altitude.
See it. Nope.
Eagle Houston, 1 minute, you're looking good.
Roger.
.130 feet vertical rise rate.
So a little bit of slow wallowing back and forth. Not very much thruster activity.
Roger, mighty fine.
$700, 150 up, beautiful. 9,000. AG degrees within a foot per second.
Eagle Houston, you're looking good at 2. Ping, zags, and missed in, all agree.
So that's 1,000, 170 up, beautiful, 14,000. And a foot per second again, Ags to ping. S-band looks like it's holding good, Houston.
Roger, we concur. It's great.
1400, 185.
Aldrin is reading the horizontal velocity first, and then the vertical velocity. It's now 1,424 feet per second vertical velocity, 187 vertical velocity.
Eagle Houston, your go at 3 minutes. Everything's looking good.
Roger. Right on H-dot. Coming up to, this is H-dot max now. I'm going right down US1.
Roger. Height's now approaching 32,000 feet.
The historical plaque on the ladder of Apollo 11's lunar module Eagle still remaining on the moon.
Everything's great.
After more than 2.5 hours on the lunar surface, they had left behind scientific instruments such as a restore reflector array used for the lunar laser ranging equipment. They also left an American flag, Apollo 1 mission patch, and a plaque bearing 2 drawings of Earth, an inscription and signatures of the astronauts and Richard Nixon. They also left behind a memorial bag containing a gold replica of an olive branch as a traditional symbol of peace, the Apollo 1 patch, and a silicone message disc. The disc carries the goodwill statements by Presidents Eisenhower, Kennedy, Johnson, and Nixon, and messages from leaders of 73 countries around the world. The disc also carries a listing of the leadership of the U.S. Congress, a listing of members of the 4 committees of the House and Senate responsible for the NASA legislation, and the names of NASA's past and present top management.
Eagle Houston, you're great.
3,
looking good.
155.
All 3 data sources are agreeing quite closely here. The 3-color plot board on the front of mission control here is almost superimposed, as each of the 3 colors are scribed on the scribing plotter.
Brian also sounding good. It's buff to the right.
Eagle Houston, you're still looking mighty fine.
Roger, good agreement in Delta V to go and both Ags and ping.
Roger.
One minute to go in the burn. 4,482 feet per second, horizontal velocity.
At 800 to go. To go. Okay, and open up the main shutoff. Ascent seat closed, pressure's holding good, cross speed off.
350 to go. Stand by on the engine arm. 90. Okay. Off. 50. Set down. We got 53373, 32.8 feet per second, 60,666. Eagle, roger, we copy. It's great. Go. And we got our residuals.
Plus 22.7, plus 1.7, minus 10.6. Thank you.
I'm showing a good bit out of plane velocity on my cross pointers, Mike.
Right, I have no indication of it. Coming up on 1 minute to tick, Neil. How's it looking?
Pretty good.
Good.
That data plane was in the Ags, not in the radar.
Roger that.
We're burning.
Attaboy. Burn complete.
3. Burn complete.
Roger, thank you.
Eagle Houston, that's Omni, low picked rate, and we'll see you at 127 plus 5-1. This is Apollo Control. We've apparently had loss of signal with Columbia and Eagle as they went behind the moon on the 26th revolution. Next maneuver scheduled for about 33 minutes from now. While both vehicles are behind the moon, this will be the braking series of maneuvers coming down to docking, or station keeping first, and then docking at about 128 hours ground elapsed time. And at 127 hours 6 minutes ground elapsed time, and the flight of Apollo 11. This is Mission Control. This is Apollo Control. 127 hours 50 minutes ground elapsed time. Less than a minute now away from acquisition of the spacecraft Columbia. Hopefully flying within a few feet of it will be Eagle. Docking should take place about 10 minutes from now, according to the flight plan. However, this is a crew option matter. We're standing by for word that data is coming in from the two spacecraft. This is Lunar Revolution number 27 for Columbia. I have LEM AOS. Roger.
Okay, Mike. I'll get try to get in position here, and then you got it. How does the roll attitude look? I've stopped. Matter of fact, I can stop right here if you like that.
Eagle Houston, middle gimbal, and you might pass to Columbia. We don't have him yet.
That's right. I'm not going to do a thing, Mike. I'm just letting her hold an attitude hold.
Okay.
You guys? Okay.
Station color has been attached.
And the collar is inflated.
The splashdown point was 13 degrees, 19 minutes north, 169 degrees, 9 minutes west. That's 1,440 nautical miles east of Wake Island, or 380 kilometers south of Johnson Atoll. 15 miles from the recovery ship USS Hornet.
This is Air Boss 1. We hold the command module on the radar bearing up 244 from Hornet at 12 miles. Fourth, the second raft is in the water, 75 feet upwind. Raft number 2 is inflated. Recovery 1 has moved in position, standing by to lower big swimmer.
Recovery 1 getting ready to deploy the swimmer with the biological isolation garments.
Roger. The swimmer is in raft number 2. Recovery 1 is in position, lowering the bag of bait at this time.
And the helo is lowering the astronauts' bigs, or biological isolation garments, to Lieutenant Heidelberg.
This is Air Boss 1, your condition? Our condition is all 3 excellent. We're just fine. Take your time. All right.
That was Mike Collins reporting the crew was excellent.
Big swimmer is trying to don it. One swimmer in raft number 1. This is Apollo 11. Everybody take your sweet time. We're doing just fine in here. It's not quite as stable as the Hornet, but all right.
Lieutenant Heidelberg is now transferring the bigs to the crew.
This is 101. Open the hatch.
Hornet now estimates they are 4 3/4 miles away from the spacecraft.
Roger. The hatch is closed.
The bigs are in the command module and the hatch has been closed again.
This is swimmer team leader. Radio check, over. Warn the astronaut to open the hatch. The first has to get out of the hatch. The first has
Astronaut number 2 coming out the hatch now.
The third astronaut is out of the hatch.
And the third crewman is out of the spacecraft now.
The swimmer has...
Hornet now reports that the swimmer is having some difficulty securing the hatch and one of the astronauts is helping him.
Secure. All 3 astronauts are at crew 1. Roger.
hatch is now reported secured. The swimmer has now started scrubbing the astronauts' biological isolations garments with the decontaminant. Hornet estimates distance 3/4 of a mile now. The other swimmers will now proceed to the command module. It has been decontaminated and the swimmers will remain on their scuba air.
Photo 1 Hornet requests you reconfirm that they are decontaminating raft number 1. Photo 1, that is affirmative. They are decontaminating raft number 1. Entered to the station. This is Hornet, roger up.
is recovery 1. I have 3 astronauts aboard, switching power frequency, power frequency.
Front is in position. Roger. Second generation. Front on it.
After recovery by helicopter, approximately 1 hour after splashdown, the astronauts were placed in a trailer that had been designed as a quarantine facility. The astronauts were placed in quarantine after their landing on the moon due to fears that the moon might contain undiscovered pathogens and that the astronauts were exposed to them during their moonwalks. However, after almost 3 weeks in confinement, first in their trailer and later in the Lunar Receiving Laboratory at the Lyndon B. Johnson Space Center, the astronauts were given a clean bill of health. President Richard Nixon was aboard the recovery vessel to personally welcome the astronauts back to Earth. On August 13, 1969, the astronauts exited quarantine to the cheers of the American public. Parades were held in their honor in New York, Chicago, and Los Angeles on the same day.
Over 100 foreign governments, emperors, and presidents.
Driven by dreams and funded by a burning desire to beat the Russians, the first moon landing on July 20th, 1969 was a defining moment in history. Never before had so many people in so many countries watched a single event with such astonishment and wonder.